Let's go for one of the best linear algebra topics where the relation between trace and eigenvalues is developed and proved, and also if a matrix A is given, A to the power of n eigenvalues are what, and what will be the trace and also determinant, and this beautiful connection is established and proved here in this lecture as a topic of engineering mathematics from Maths and Science by IITian by an IITian, and the website refers to is mathsandscience.com. Please visit this for further notes and clarifications. And it's a very good example. In this example or a practical problem, practice problem, we will prove that trace of a matrix is equal to sum of eigenvalues, and also determinant of a matrix is equal to product of eigenvalues, and when a matrix A is given, how to find out A to the power of n eigenvalues, and also determinant of A to the power of n and trace of A to the power of n. It's a very good topic, and any questions being given on this, you will be able to answer them accurately and correctly once you understand the concepts behind it. I will be explaining the concepts one by one in this example. Please pay attention till the end, and all the concepts will be clear and theorems will be proved and a simple in a simpler way so that you will understand better. Let's move forward. Here I will be directly going for the solution. It is for higher engineering mathematics, JEE Advanced, and also for CSIR mathematics, and also international university BTech mathematics students, for international and national universities. Let us take one 2 by 2 matrix for simplicity. You can extend it to any n by n matrix also. Let there be a matrix A, which is A, B, C, D, having elements. Now, from the definition of the trace of a matrix, what is trace of a matrix? Trace of a matrix is equal to sum of the elements in principal diagonal. What is the principal diagonal here? This is the principal diagonal, yellow line, and that is equal to, it is written as, trace is written as TR A. The trace is equal to A plus D, sum of the elements. This is from the definition, straightforward. Then we have to prove that this trace of a matrix is equal to sum of the eigenvalues. That is our first proof. Then we will go for determinant next. What is to be proved? Prove that trace of A is equal to sum of eigenvalues. That I can write sum of lambda I. This is what I have to prove. Lambda is the eigenvalue. How to find out the eigenvalue? There is one formula called characteristic equation. We have to develop this. Characteristic equation. We have to develop this equation which says that lambda I is equal to eigenvalue, then determinant of A minus lambda I is equal to 0. Here what is I? I is equal to identity matrix 1 0 0 1 in our case, because we have taken 2 by 2 matrix. If you take 3 by 3 matrix, 1 0 0 0 1 0 and 0 0 1. For 3 by 3 it is 1 0 0 0 1 0 0 0 1. This is equal to I3. This is equal to I2. It is 2 by 2 matrix we have taken as an example here. Now, what is A minus lambda I? A minus lambda I is equal to A is A, B, C, D minus lambda into I is 1 0 0 1. That implies A minus lambda I is equal to A, B, C, D minus lambda into 1, 1 into lambda, 0 into lambda, 0 into lambda, 1 into lambda. When you multiply I with lambda, then this will be equal to A, B, C, D minus lambda 0 0 lambda. If two matrices are added or subtracted from each other, the respective elements will be added or respective elements will be subtracted. In this it is subtraction. That means A minus lambda I is equal to A minus lambda B minus 0 C minus 0 D minus lambda. This implies A minus lambda I is equal to A minus lambda B C D minus lambda. Determinant of it is a characteristic equation. Characteristic equation is equal to determinant of A minus I lambda is equal to 0. We know what is A minus I lambda. Hence, we require determinant of A minus lambda B C D minus lambda, that is equal to 0. That implies, from the basics of matrices, these two should be multiplied and these should be deducted from that multiplication value. That is the determinant. A minus lambda into D minus lambda minus BC is equal to 0. These are all things explained in my 350 videos which I have already published in Mathematics by IITian on different occasions. You can see the matrices, definitions and matrices elementary operations. Now, what will be its value? A D minus A lambda minus lambda d plus lambda square minus bc is equal to 0. Then what it happens? AD minus BC. The values of constant values are taken on one side. Minus lambda into A plus D plus lambda square is equal to 0. This is the characteristic equation. Now tell me, what is the value of A plus D here? Can you guess? We have already seen from the definition of trace that A plus D is equal to trace. Can I write it like this? Lambda square minus lambda into trace of A plus AD minus BC. And another important thing here we have to make a note. What is this AD minus BC? Expect something from it. From the definitions of matrix A, B, C, D. What is the determinant? Determinant just now told you A and D will be multiplied and B and C will be multiplied and subtracted. Determinant of A is equal to AD minus BC. Do you agree? From these two, we can write that lambda square minus lambda into trace of A plus determinant of A is equal to 0. This is the characteristic equation of a 2 by 2 matrix. Now, the value of lambda, there will be two values for lambda because it is a quadratic equation. From the quadratic equation, please remember your 10th class mathematics, algebra, basic algebra. If a quadratic equation is ax square plus bx plus c is equal to 0, that implies sum of the roots and product of the roots. Compare it with whatever we have got here. Lambda square minus lambda into trace of A plus determinant of A is equal to 0. Here, what you can deduce from there? A is equal to 1. Because lambda and x, let us compare. Rather, without ax square plus bx plus c can also be written as a lambda square plus b lambda plus c is equal to 0. Let us compare these two. A is compared a lambda square is compared with lambda square, hence a is equal to 1. What is b? B is equal to minus trace of a, and c is equal to determinant of a. From the basics of your ax square plus bx plus c, when we have sum of the roots is equal to minus b by a, that is minus of minus trace of a divided by 1, that is trace of a. What is the sum of roots? If a lambda square plus b lambda plus c is equal to 0, then roots will be lambda 1 and lambda 2, which are eigenvalues. Hence, it is proved that lambda 1 plus lambda 2 is equal to trace of A. Proved. Sum of eigenvalues is equal to trace of A. Now, from the basic equation of ax square plus bx plus c is equal to 0, what is the product of roots? Product of roots is equal to c by a, that is equal to c by 1, that is equal to determinant of A. C is nothing but determinant of A. Please compare here. C is linked to determinant. B is linked in this way and A is linked in this way. That implies sum of eigenvalues is equal to trace of A and product of eigenvalues is equal to determinant of A. These are the two theorems we have proved. Now we are left in the question left with to find eigenvalues of a to the power of n. That's what. Here determinant is equal to lambda 1 into lambda 2. Sum is equal to lambda 1 plus lambda 2. Now, to find eigenvalues of a to the power of n. When we say that there is a eigenvector, and it's not equal to 0. Then if there is an eigenvector, for eigenvector definitions and other things, you please refer to my previous lectures. If there is eigenvector V, then A into V is equal to lambda into V, where V is the eigenvector. Please remember this. This is another concept which you have to remember. This is from the definition of eigenvector, AV is equal to lambda V is given. But we have to find out A to the power of n is equal to how much? By the mathematical induction, we can prove that A to the power of n into V is equal to lambda to the power of n into V. By mathematical induction principle. You apply the mathematical induction. It is given. Let's prove it here. It is given that AV is equal to lambda V. If n is equal to 1, A to the power of n into V is equal to lambda to the power of n into V. If similarly, it implies that A to the power of k into V is equal to lambda to the power of k into V. Then what happens? A to the power of k plus 1 into V is equal to A into A to the power of k into V, that is equal to A into lambda to the power of k into V, because A to the power of k is equal to lambda to the power of k. That is equal to lambda to the power of k into AV, that is equal to lambda to the power of k into lambda V, that is equal to lambda to the power of k plus 1 V. That implies A to the power of k into V is equal to lambda to the power of k into V, and A to the power of k plus 1 into V is equal to lambda to the power of k plus 1 into V. That implies A to the power of n into V is equal to lambda to the power of n into V. As V is not equal to 0, which we have assumed the eigenvector is not equal to 0 in the beginning itself, before applying the mathematical induction principle. That implies this is for one particular vector. The eigenvalues of the given matrix for different vectors will be, because it is a 2 by 2 matrix, we can say the eigenvalues of A to the power of n will be lambda to the power of lambda 1 to the power of n into not into lambda 1 to the power of n and lambda 2 to the power of n. That means in overall sense what we have proved in this lecture is 1. Sum of eigenvalues is equal to trace of a matrix A. Second, product of eigenvalues is equal to determinant of A, and trace of A to the power of n is equal to lambda 1 to the power of n plus lambda 2 to the power of n and so on, and determinant of A to the power of n is equal to lambda 1 to the power of n into lambda 2 to the power of n into lambda 3 to the power of n and so on. And there is one question given in the GATE 2026 on this principle. Let us try to solve it. What it is given? If you have seen the question paper of 2026, this particular problem can be solved once we know the concepts and prove them perfectly. We can solve this type of problems in few seconds. It will be very easy. I am searching for the question. I will give you the question and we will try to answer it, and you can see how the simple it is to apply once the principles are known to you and once the concepts are known to you. For example, a matrix A is there, 3 by 3 matrix. The eigenvalues are given as 1, 2 and 3. Lambda 1 is equal to 1, lambda 2 is equal to 2, lambda 3 is equal to 3. 3 by 3 matrix. Then it is asked to find out trace of A square. Find trace of A square. What is trace of A to the power of n? What we have deduced? You see, it is a one step, simple, few seconds problem. Solution is trace of A to the power of n is equal to lambda 1 to the power of n plus lambda 2 to the power of n plus lambda 3 to the power of n and so on. That implies trace of A square is equal to, what is lambda 1? Is 1. A square, it is n is equal to 2. That is A square, 1 square plus 2 square plus 3 square. What is its value? This is equal to 1 plus 4 plus 9. That is equal to 14. How much time it took? Less than 10 seconds is the answer. Once you know the concept, you will be easily able to answer this question. It is given in GATE 2026. I will be developing the concepts for you on various aspects in all the topics of, to the most possible topics I will try to cover, and I will try to see that topics are covered to the most possible concepts I will provide you, and thank you for listening to me. Best of luck. Thank you for viewing my lecture. If you feel there is a value addition because of this lecture to you, kindly hype this lecture, kindly share this lecture, kindly subscribe to my channel as a token of appreciation and encouragement. And my channel name is Maths and Science by IITian. I give lectures on around 350 lectures are released, video lectures on various topics of Maths Olympiad, JEE Mathematics and Higher Mathematics, and this engineering mathematics I have started now in this YouTube channel. We will be continuing this engineering mathematics classes also along with other mathematics classes. SAT and GRE also I am discussing and really publishing the lectures. Now, there is a website called MATHS&SCIENCE.com by me. It's a very good channel. Please visit that and see for the detailed notes of almost all the lectures I am releasing, and it is aggregated into different types, different notes, and you can view them. Even I am embedding the videos whatever I am releasing on YouTube. It is started only few days back. It is under development. You can see and you can visit this also. I am adding one by one blogs and notes so that for clarity you can visit this website and get the clarification, and for notes you can visit this website. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Thank you.